Section 5.2 is on voting methods. Example 1. Students are voting for their class president, and the candidates are Omar O., Anna A., and Helena H. They have ranked the candidates according to their preference. We can organize these results into a preference schedule. We'll look at the first person who voted, and we see that they chose Anna for their first choice, Omar for their second choice, and Helena for their third choice. We'll count to see how many people voted that same order and put that number in our preference schedule. Next, we'll look at the next person who voted, Anna. Anna chose herself for the first choice, Helena for second choice, and Omar for the third choice. We'll look through and see if there are any other people who voted that same order of preference. Looks like we have 3, so we'll fill that into our preference schedule. We'll write down the order, A, H, O, and 3 voters choosing that order. Next, we have Marv, who voted for Omar in first choice, Helena for second choice, and Anna for third choice. There are 3 others who voted that same order. And the last one that we're looking at is Hannah, Anna, and then Omar. There are 3 people who voted that order as well. Once we fill in all of that information, we now have our preference schedule, which can be used to determine the winner of the election. We'll do that here in example 2. It says find the winner of the student president election using the plurality method. Plurality is the most votes. So our 3 candidates, once again, are Anna, Omar, and Helena. Looking at first choice only for plurality, we'll see that Anna shows up in the first choice section twice. We can take the sum of those 2 occurrences to find that Anna got a total of 4 first place votes. Omar only appears once for 3 first place votes, and then Helena appears once for 3 first place votes. Looking at what we have, Anna has 4, the others have 3, so Anna wins the election via the plurality method. Plurality gives us the person who gets the most votes, but often we want to know the majority. So example 3 says to find the minimum number of votes needed for a majority win in a race with 20 voters and in a race with 23 voters. Majority means more than 50%. So to find the minimum number of votes needed for a majority, we need to first find out what is 50% of the voters, and then we want more than that. In the case of 20 voters, if we take 20 and divide by 2, we see that half of 20 is 10. 10 voters would be 50%. But for a majority, we want more than 50%. So we would need 11 votes to win this election with a majority vote. If there are 23 voters, half of 23 is 11 and a half. That would be 50% of the voters. However, we want more than 50%, so we're going to round that up to the nearest vote, which would be 12 votes needed to win the election, giving you a majority votes. For our last example here, example 4, we're going to look at insecure voting. This problem says to consider a city council election in a district that is historically 60% Democratic voters and 40% Republican voters. Even though city council is technically a nonpartisan office, people generally know the affiliations of the candidates. In this election, there are 3 candidates, Don and Key, which are both Democrats, and L, a Republican. A preference schedule for the votes looks as follows. If we look at a preference schedule, we see that by plurality, L would win this election. However, if we think about the historical percentages for Democrats and Republicans, with Don and Key both being Democratic, if we were to add up their total number of votes, we would see that there are 483 people who voted for a Democratic candidate, which is more than the 342 votes that went towards the Republican candidate. So in this case, we're looking at an election where you might say that the vote was split among the Democrats. There are 483 who voted Democratically. However, because there are two Democratic candidates, some of the votes went to Key and some of the votes went to Don. Say that a voter is thinking about how much value their individual vote will make. They might want to vote for Don, but thinking about the outcome of the election, they might realize that Key might be the more popular candidate out of the two, and they don't want L to win at all. So someone might choose, instead of voting their true preference of Don, they might choose to vote for Key to guarantee that even if their person, Don, doesn't win, at least another Democratic candidate would win. And that would be considered insecure voting. If someone votes different from their actual preferred choice.